got to the end of thanking people, so now we can get on with the talk. The talk does exactly what it says in the title. It has a look at how we're predicting AGI, and its conclusion is that we need to increase uncertainty, spread those error bars, and add caveats to our predictions. Now, one hint that this may be necessary comes from looking at some past predictions. Like this is from the famous Dartmouth conference in '56, where they basically seem to imply that we would have AGI or something like it within a few months. 9 years later, Dreyfus was predicting that basically we'd reached about the limit of what computers could be expected to do. I think it's safe to say that neither of these predictions have been entirely borne out in practice. Here's another prediction. We will have AGI in 15 to 25 years. It's a slight paraphrase. Who do you think predicted this? Well, various people predicted it actually this year. Also in 2011, 2010, 2009, and quite a lot of other dates, many of which are considerably more than 25 years ago. We should be able to do better than this. So this talk will look at AGI predictions, timeline predictions, and a few philosophical predictions, asking two questions: what performance should we expect from these predictors, and as far as we can tell, what performance are we actually seeing? It's going to make extensive use of the Singularities Institute's database of 257 AI predictions, going back to the 50s. They got a bunch of volunteers to scour the literature and the internet to find these predictions so that I didn't have to do it myself. What performance do we expect? This is XKCD's cartoon of various fields arranged by purity, and everybody sneers on the less pure subject. Quite conveniently, this is also fields arranged by how solid their predictions are. Let's make a little bit of space and add economists about down here and historians. Now, why is it that, for instance, when a physicist says this is what we're going to see as the result of an experiment, we should listen to him a lot more than if a sociologist says a similar thing? Well, it's mainly because these different fields have access to different methods. From mathematicians and their deductive logic, we work down through various hard and soft versions of the scientific method, and end up down with the poor historians who are limited to using nothing but past examples. Now, where should we put AGI predictions on this graph? Well, there's a convenient slot just down here on the left. And that is indeed where we should put AGI predictors, mainly because they can't use any of this pretty much. We don't have a single example of a successful AGI. So we're dependent on nothing but, expert opinion. And expert opinion on its own is a lot less reliable than the other methods up here. Now, another thing, you might think as you move down this graph there, that as the conclusions become less certain, that the experts become more tentative, more modest, and more willing to engage or accept opposing points of view. No. Just one example, let's choose economists. Here is Paul Krugman waxing lyrical about Chicago School economists. Here's a Chicago School economist responding in an equally generous manner. Now, I should point out that economics is a field where average quarterly GDP is adjusted by plus or minus 1.7% on average. These are not predictions, this is past data. And this is often the difference between a large growth and a recession. And this is the adjustments done to past data. And if this is the quality of the data in their field, we should expect a lot more modesty in conclusions and predictions. But as I said, this is where we are. And this is extremely annoying because these two people know stuff about economics. They have wisdom, they have experience, and we'd really like to unlock those ideas and use them for ourselves. But as long as they're sort of saying completely opposite things, we just can't get access to that wisdom. This is the cartoon picture of disagreements and overconfidence. Within our heads, we have a bunch of good reasons to believe what we believe. We also have a large amount of biases and rationalizations. And all this leads to a reasonable seeming conclusion. Our opponents are in exactly the same situation. But from within our heads, all that we can see is this. So what this means is that no matter how right it feels to you inside, you must give your opponent's opinions as much respect as you give your own. No matter how much you feel that you're right, because you're feeling this and that also exists in their heads, except you just can't see it. The exception being, of course, if you have actual objective reasons to suppose that one person is an expert and knows more than the other. And when I'm saying that objective reasons, it's not just that everybody gets to choose what their own objectivity criteria are. Fortunately, we have some research into what makes a good expert opinion. It depends mainly on the task. There are some tasks in which experts have good performance, others in which they have poor performance. The ones that have the features on the left, you have good performance. The ones that have the features on the right, you have poor performance. These are not equally important. Three of the most important ones are whether experts agree or disagree, whether the problem is decomposable or not, and probably the most important of all, whether you get immediate feedback for your predictions. In terms of predicting when AGI is going to happen, we're kind of probably stuck on these ones. So we should generically expect poor performance from expert predictors. That doesn't mean if you're making your own prediction that you can't do all that you can to move it onto the good performance slide as much as possible, especially through, for instance, decomposing the problem. But very few predictors actually do that. And part of the reason, I suspect, is that they're solving the wrong problem. In the FHI, we have a sort of shorthand that predicting grind, that's a coffee grinder there, predicting grind is easy and predicting insight is hard. Grind is something that will happen because a certain amount of work is done at it. For instance, how long will it take to produce the next Michael Bay blockbuster? Well, if you think about it, a blockbuster is a huge thing. You have artists, you have marketers, you have actors, you have producers. All these people need to work together to produce one blockbuster, or attempt at a blockbuster. But it turns out that even though it's a vastly complicated project, all that you need is a certain amount of people to work at it for a certain amount of time, and the blockbuster will emerge. And we have a pretty good timeline for how long that'll take. We also have pretty good estimates for how many unexpected delays we'll get. Let's contrast that with insight. Who would want to predict when someone will solve the Riemann hypothesis? This is a much harder task. And very often when in AGI predictions, people are predicting insight but actually pretending that they're predicting grind. The most typical example of this is various incarnations of Moore's law, hence AGI, which the argument goes, by some year computers will have some level of Y, I don't know, floating operations per second, something along the hard disk capacity or whatever, that is a level comparable with the human brain, hence AGI. Now, the Moore's law is basically grind. People work at it, computers get faster. So this looks like a good prediction. The grind part of it is a good prediction. But the most important part is why, when we get that number of neurons, number of floating operational centers, will we get AGI? That requires an insight to bridge that. And very often people put up these kind of predictions with making no effort to bridge that gap at all. But anyway, that's enough theory. Let's look at the evidence. So this is the Singularities Institute's database of 257 predictions. 95 of them were timeline predictions. Unfortunately, they're not all in the same format. They're not all, well, an expert saying, by golly, I predict we'll have human-level AGI by the year XXX. I went through them, and to each one I gave a median human-level AGI estimate. This is somewhat subjective for some of the predictions. If you want, you can go online and come up with your own predictions from the data. It is available. For each predictor, we also assess the expertise of the predictor. Presumably, computer scientists know a lot more about this than journalists or writers. So what did the data look like? Well, it looks like this. There's also a few predictions above 2,100. Here, incidentally, is Turing's original prediction, and you can even make out the AI winter in the middle of the data. Now, the first thing that strikes me when I look at this is that it's all over the place. Take two predictions, you could easily get 20 years between them, if not more. It seems to bear out. So what we thought that, in theory, AGI predictors would be pretty poor seems to be borne out by the data that we have. Also, there's no immediate difference between experts and non-experts. You can sort of see small patterns, but nothing determining. Now, there's two sort of folk explanations as to why we should expect AGI predictions to be so poor. One is the so-called Maes-Garrow law, which is that basically people predict that an AI will happen just before they die. It's a rapture of the nerds. AGI will happen, they will be saved. There is actually no evidence for this in the data. Here we've plotted the prediction minus the life expectancy of the predictor. These are the predictions of people who expect to die before seeing AGI. These are the ones where the AGI will happen more than 5 years before they die. There is no strong clustering around 0 as we would expect if the Maes-Garrow law is true. The second folk explanation is that everybody predicts it 15 to 25 years in the future. A cynical explanation would be that it's close enough that people will give you money to research on it, but far enough that no one will be able to call you on your mistakes until you've moved on to another career. There might also be some psychological explanations in that it's hard to conceive of something that you're sure will happen, but it'll take more than 3 or 4 technology cycles to happen. Anyway, whatever the explanation, there is evidence for this in the data. Consistently, about 1/3 of predictions are in the 15 to 25 year range. This is the time to AGI for everyone. This is the time to AGI by experts. This is the time to AGI by non-experts. And perhaps more damning of all, this is the time to AGI by predictions that have come and gone. Now, seeing how little data we actually have, a few data points we actually have, these curves look really pretty similar to me. And so it might be that the experts actually do know what they're talking about and have extra insights that non-experts don't, but there's definitely no evidence of it here. Now, but remember, just because the experts don't seem to be any good, doesn't mean that your own guess is any better. Your guess is probably as good as an expert's, which means no good at all. Now, what can we do about this? Well, the first thing is to increase uncertainty. That helps with everything. Suppose you say AGI is going to happen at 2040, and you're very certain about this. Well, what you're saying is that all those experts are wrong, deluded, confused, and mistaken. You're not only saying that you're right, but you're saying that so many other people are wrong. Let's say that you're saying it's pretty likely. Well, now the number of people who have to be wrong for you to be right goes down considerably. Now let's say that you're saying it's an approximate guess. Now suddenly there's broad agreement. By the way, feel free to increase the experts' uncertainty bars. You can be sure that everybody is overconfident in this area. Now, another justification for why we should increase uncertainty comes from looking at what I feel is the best timeline prediction, which is the prediction of the whole brain emulations, which you'll be hearing about in the second session today. Basically here you fix a brain, slice it up, scan it, and instantiate it on a computer using less crude technology than depicted there. Now, why do I say that this is a good timeline prediction? Well, because it's a very decomposed problem for a start. Also, it's justified why most of this can be solved by grind. It expects there is Moore's law, there is research being done, and there's justification why, after a certain amount of work, we should expect certain types of results. There's clear assumption scenarios, it integrates new data to a certain extent, and there's multiple pathways to the same thing. My colleague Anders Sandberg has run Monte Carlo simulations under 3 assumptions for how long it would take to get whole brain emulations, and these are the probability distributions that he got. As you can see, it's spread over nearly the entirety of the coming century. And if these are the uncertainties and error bars for our best timeline prediction, then any other type of timeline prediction should probably have error bars at least as big as this one. So what can we say about AGI? Timeline predictions are pretty poor. Other types of predictions, such as plans for how to build AGIs, tend to suffer from similar problems. Now, we can actually get some good ideas about AGI from philosophy. Now, this may be a very contentious thing to say to most of the computer scientists in the audience, because their vision of a philosopher is probably of someone who says inane things like this, to which the self-respecting computer scientist can only respond, well, not really. And then the philosopher hits back with a hard-hitting intellectual argument, and the conversation continues in a similar intellectual fashion. But the thing to remember is that philosophers are experts, which means they're massively overconfident. So if you want to take their arguments, you need to add more caveats, more uncertainty, decompose the problems as far as you can get. So let's just take this inane good-else theorem thing and decompose it and caveat it a bit. And when it's done that, it basically reduces to the rather reasonable position that self-reference might be a problem in AGIs, and you should probably keep an eye out for that. And then you can actually get a conversation going. I mean, philosophy has had a few success stories in the past. Some of these may have been considered useful at one time. But let's give some examples of how you can improve philosophical arguments. This is Dreyfus's Computers Can't Cope with Ambiguity paper. Incidentally, the 65 paper is worth looking at. I think it would have got a lot more respect if it hadn't been so abrasive and insulting to all the computer scientists at the time, but there are some genuine insights inside it. But let's caveat that argument, and we can reduce it to the far more reasonable and actually true argument that using 1965 AI approaches, you can't cope with ambiguity. Let's have Gosse's more recent prediction by Gosse, which is identifying the computer with the brain may be a mistake. Computing isn't thinking. If you weaken this, you get the reasonable point that AGIs may be nothing like human brains, and that we may go astray by thinking that they are. Now, I've had to look at a lot of philosophical predictions for this paper, and in my opinion, the best one around currently is what I'm going to call the Omohundro-Yudkowsky thesis, bashing the two ideas together. In its strong form, it's that behaving dangerously is a generic behavior for high intelligence AGIs. This is kind of the supply and demand model for AGI. It makes simplifying assumptions as to what these agents are going to look like. But like any, like the supply and demand curve, it still has very useful insights. Right, if we refine and narrow the thesis, we have the descriptive part, which is that many AGI designs have at least the potential for unexpected dangerous behavior. And the prescriptive, that AGI programmers should demonstrate to moderate skeptics that their designs are safe. I don't mean that you necessarily have to convince Omohundro and Yudkowsky of this, but it would be good if you could convince people sort of not in your programming group, for instance. Now, you may have the feeling that this thesis is wrong. But from what I've shown you before, unfortunately, your own feelings don't actually mean anything here, unless you have some strong evidence or reasons to back it up. Fortunately here, there's a very easy way to destroy this thesis. I draw your attention to the second clause again. Now, in conclusion, so our own opinions are not strong evidence of anything. Philosophy has some useful things to say. One of the main reasons why philosophy has some useful things to say is that other methods, such as timelines, are so very problematic. And finally, but towering above all others, and in philosophy, in timeline predictions, in everything, I encourage you to increase your uncertainty. And I just want to thank everybody who's been involved in this, and especially thank anyone who's had the courage to go out on a limb and actually write down an AGI prediction. My data can be found there if you want to have a look at it.
We have time for a few questions for Stuart. Okay, I see your hand up here.
Just wanted to caveat the point about what these predictions teach us. Jim Light, these predictions were predictions made public, and most of them self-selected. So if we shouldn't confuse the distribution of the predictions that we hear, that we see in the media, that go into this distribution, and what you get if you ask an unbiased, unselected sample that's representative of the relevant population. And looking actually at the surveys, so the surveys for the past AGI surveys, there was one at the AGI 2008 conference, the AI at 50 conference, and then things working with a broader group of academics who were not at a conference specifically because they thought that AGI was promising, et cetera, et cetera. You find that the timelines go out, the less there are in the way of these plausible selective factors. So I think if you're just a random person in society, the random person's predictions may actually be better than the predictions they see in the media, because those are just the most optimistic of the predictions. The people with more pessimistic predictions never bother to make a big deal about them because they think it's not an important issue.
So, yes, do be aware of selection bias. I worked with what I could find. So about optimistic, I mean, there were some very pessimistic ones there. I didn't plot them all, but there were some sort of 200-300 years time. But your point is interesting. So So maybe that it's not a 15 to 25 years law, maybe it's a 30 to 40 years law in private predictions. Yes?
In your short list of the useful contributions of philosophers, there was
Of philosophy.
okay, what we are doing. There were preciously few things past 1930. And I would probably put Church and Turing in our camp, not in yours. Actually, quite definitely. And I find that a lot of the discussion that goes on in the field of philosophy is still stuck at the level of Turing's 1950 paper. So for me, of course, the question would be, what can we do to make philosophy useful again for us? How can we get philosophy to engage with us in a way that is not like the famous Inkompetenz, Kompensationskompetenz. That would be in English the competence to compensate for your incompetence. That's something which, of course, philosophy had to harness after sciences were subtracted from it and became independent. I do think that philosophy, of course, has a lot of things to say and it's very useful, but how can we use it, make it useful for FHI to engage over those boundaries?
Well, yes, I do agree with you that there are some disastrous predictions in philosophy. And I would claim the Church-Turing thesis as a philosophical prediction, as a philosophical thesis, because it's connecting computation and it's not something that could emerge just from, say, programming. But, so for how to make it, well, I mean, the FHI is partially doing that. We're trying to bring philosophical results to bear on AI problems, so I think impartially you should give more money to the FHI. But apart from that, let's see. Organize more mixed conferences like this would be a good idea. I think it's probably more the job of philosophy to try and reform itself to come closer to bringing useful results to AGI. So probably the best thing that the computer scientists can do is to pay attention to useful philosophical results and highlight them. And this might incentivize other philosophers to start thinking what sort of practical help they could bring.
I think we have time for one or two very quick questions.
I shouldn't start my presentation yet, however, it refers to both. One is the prediction to the next presentation, but it is a question to you. You haven't mentioned the term foresight in your talk, neither in your talk nor in the paper. And in fact, by prediction, you mean a statement which was issued by someone backed on intuition, backed on scientific research, backed on the experience on the whole life and so on. You have shown a lot of disadvantages of them. However, when you say most predictions were false or not justified enough, have you found any optimistic way of making such predictions or statements about the AI future? Have you formulated any, I would say, a hint to the researchers to produce good forecasts, good predictions?
Yes. The key thing seems to be try and check what bring out the hidden assumptions. Don't make a breezy. Don't count on your gut to come up with something decent. Try and imagine how what you're talking about would come across, would come to being. The decomposing the problem is probably the single easiest thing that can be done. There are some decomposed predictions, like Ben Gribsel's prediction, for instance, for open cog seems very well decomposed. Kurzweil's predictions are decomposed up to an extent, but it does the things get more powerful, AGI kind of appears. So probably the best thing you can do is decompose your prediction as much as possible, and when you're saying AGI will appear here from that or because of that, make explicit what assumptions you need to bridge that gap. So if you say a fast enough computer will make AGI happen, put down some reasons for that. Why? Is it today's algorithms are enough if we make them faster? Or is it that you're expecting algorithms to progress at a certain rate?
At this point, in the interests of getting a little less blood into my caffeine stream, I'm going to move on to the last talk of this session, but I do encourage you to grab Stuart in the coffee break and pepper him.